All right, I'm back. We're still on page 294. I just want to review some things before we do the last problem that's on the page. So the things that I wanted to take a look at are these, the same things that we started with, right? So differentiable at x equals a means f prime of a exists. That's all it means. Differentiable on an interval is like a better thing to know because then you don't have to worry about each individual point. So if you're differentiable on the interval from a to b, then f prime exists everywhere between a and b. Notice that's an open interval, so we're not talking about at A or at B. We don't really know in that case. And then if we can just say that a function is differentiable, that means that the domain of the derivative is the same as the domain of the original function. So at every point where f of x exists, f prime exists. If there's any point at which f prime doesn't exist, but f of x exists, then we'll say the function is not differentiable. So it could be differentiable at every other point, meaning that the derivative exists at every other point. But if there's one point in the domain of the function at which f prime doesn't exist, then it's done. Can't be differentiable function. It's kind of annoying. All right, let's see. So here we go. F of x is x squared, nope, x to the negative second. State the domain. So x to the negative second is really 1 over x squared. That's how I always think of that, which means you can't divide by 0. So the domain of f of x is x is an element of the reals, x is not 0. Okay, so for this to be a differentiable function, when we find the derivative, the domain of the derivative needs to be all reals except 0. So the derivative can't exist at 0 because the function doesn't exist there. The real question will be, is there another place where the derivative doesn't exist? And we're going to find out. So let's see. First, let's find f prime of x. All right, so I'm thinking of, I'm thinking of f of x as 1 over x squared to make my life a little easier. So what I'm going to do is f prime of x is the limit as h approaches 0 of f of x plus h. So 1 over x plus h squared minus f of x over h. Okay, so common denominator here. Common denominator in the numerator. Limit as h approaches 0. I'm also going to simplify complex fractions at the same time. So I'm looking at, let me just highlight what I'm looking at. I'm looking at, going to need a bigger highlighter. I'm looking at this, right? So I'm working on that. That's a very light highlighter, but I think you can probably see it. So on the left-hand fraction, I need x squared over x squared. So I'm going to end up with x squared. On the right-hand fraction, I'm going to need x plus h squared over x plus h squared. So x plus h squared over. So the common denominator in the numerator is x squared times x plus h squared. But it's complex fraction, so I'm also going to put the h. I'm going to put this different color. I'm going to put this h. Wow, that's a big highlighter. That h is going in the overall denominator now. So you should definitely practice that. There's a lot of videos of me dealing with complex fractions. And if this is a struggle for you, fix that by watching some videos. So we get this. All right. So I guess I'm going to keep going horizontal here. Some teachers freak out if you work horizontally. I'm not one of them, obviously, because I seem to always work horizontally. All right, could I do a difference of squares here? I could, but it's just easier to expand everything. So minus x squared 2xh. It's like essential that I not screw this up now that I said that it's easier. Over h, x plus h squared, x squared. All right, how much more room do I have to go? All right, at this stage, if everything without an h doesn't cancel out, you know that you messed up, which we saw last time I messed up. I don't know if that was the last time. Recently. All right, so x squared minus x squared gone. I'm also going to cancel the h, so I'm going to end up with negative 2x minus h, because I canceled the h in the denominator with everything in the numerator that had an h, and then x plus h squared, x squared. Okay, and then this, good grief, is the limit as h approaches 0 of, h is going to be 0. Actually, I don't need the limit anymore because I can actually take the limit at this point. So I'm going to not put the limit. I'm just going to do negative 2x over. So if h is 0 in the denominator, I get x plus 0 squared is x squared times x squared is x to the 4th. So I get negative 2 over x cubed. All right, so I feel like I should summarize that over here maybe and say that f prime of x is negative 2 over x cubed. Okay, domain of f prime is, not equal, is, so x is still an element of the reals and x is not 0. Okay, so look at that. The domain of the original function was x is an element of the reals, but x can't be 0. The domain of the derivative is x is an element of the reals, but x can't be 0. They have exactly the same domain, therefore the function is differentiable. So I'm going to say, since f of x and f prime of x have, that says have, but man, does it have same domain, f of x is differentiable. That's what we needed. F of x is, so I'm going to start abbreviating differentiable as diff, which you can also do. So f of x is different. I mean, on the AP exam, I would write out differentiable because, like, what's your rush, right? Get your perfect 5 and move on. But here, there are your notes. I'm going to abbreviate it as differentiable. So that was basically the problem. We still haven't really seen a function that's not differentiable, which is okay because we're getting there. I'm going to end this video here, come back in the next one, and keep going. So I think we're making good progress. I hope you're thinking about these ideas because it really does take some thought. You can make up your own functions. I would stick to polynomials right now and go through the process, write your own tangent lines, things like that. But anyway, I hope these videos are helpful, and I will see you in the next one.